When I look at an electrical storage system, there's two numbers I look at right away. One is the capacity. How many kilowatt hours or megawatt hours can this system deliver? Perhaps we have a 10 kilowatt hour system. This is a description of the energy which is stored in the system. The other number that gets my attention really quick is the power rating. And this tells us how fast can the energy be released. Perhaps the system can release energy at a rate of 1 kilowatt. If you know two of these numbers, you can figure out the third. You may recall the equation that tells us that energy is equal to the product of power and time. So if you knew the energy was 10 kilowatt hours, and you knew the power was 1 kilowatt, you could calculate the amount of time that it could deliver this energy. In this case, it's 10 hours. As another example, consider that pumped hydro system that I described in the introductory videos. That system was rated to deliver a maximum power of 10 megawatts, and it could do so continuously for 2 days. From this, we can calculate the energy. We could leave it like this, but megawatt days is not a convenient measure of energy. Instead, let's convert it to megawatt hours or kilowatt hours. Much better. You see, 480 megawatt hours is a description of the amount of energy that is contained in that system. 10 megawatts, on the other hand, is a description of how fast that energy can be released from the system. Let's draw a quick picture to see what we mean. If you remember, there are several parts to our pumped hydro system. We have the upper reservoir, the lower reservoir, and we have the turbine. The turbine is mechanically coupled to this device here, which can operate as either a motor or a generator, depending if we want to store energy or if we want to retrieve energy. Now we can go back to our specifications. We have this one, which tells us that it's 10 megawatts. Again, that's a power. And then we have this one, which tells us we have 480 megawatt hours, which is the energy that's stored in the system. So we can associate 480 megawatt hours with the upper reservoir. The energy stored is the amount of water in the upper reservoir. So when the reservoir is full, it can provide 480 megawatt hours of energy. This other specification, this 10 megawatts, is a description of the machinery. It tells you how fast this generator, or motor, depending on which way it's operated, can absorb power. It's really a question about how big the machinery is. It could have been built larger and heavier, in which case it might have provided more power. But you'll notice it wouldn't have changed the energy. The energy is still a function of how much water is held in the upper reservoir. One more quick example, then we're done. Let's talk about the battery energy storage system. You'll recall that system had a battery and a power converter. Once again, when you see a system like this, you want to ask yourself two questions. What is the energy storage capability, and how much power can it deliver at any moment in time? The energy capacity is a function of the battery, and the amount of power that can be delivered is a function of the battery and the converter. Just like the pump hydro, when we talk about power, it's really a question of the machinery. This converter, for example, will be rated to deliver so much power. If you exceed that, it could overheat and be damaged. Likewise, the batteries. Sure, they may store lots of energy, but there's going to be a limitation to how quickly it can deliver that energy to the outside world.